Okay, here we've got example 4, a canoeist. All right, so we're canoeing. So this one requires a lot of your own thought process to it. Actually, a lot of students they like this question a lot. They don't, well, let's just say they don't like it. So mentally prepare. But I'm here to help you, right? So I'm here to give you all the help that you need. If you have questions, email me. A canoeist paddled for 4 hours with a 6 km/h current to reach a campsite. The return trip against the same current took 10 hours. Find the rowing speed in still water. Okay, so when it asks for rowing speed in still water, basically, what is our speed? So as a person, what is my rowing speed? If I was set in like a giant pool and someone just said, okay, row. Basically, what is the speed that I can go at? So let's get the picture set up for us. So we've got this person in the canoe, right? We're happy, we're excited. We are in water. So we start here. And then we go to our campsite. X marks the spot. Maybe that's our little fire for the night, right? Ooh, fire, fire, fire. That's where we sleep. We end up, right? So, it took us how long to get there? Let's see, 4 hours. And then the return trip home took us 10 hours. I know that the speed of the water is 6 km/h. So what we need to know for this is first off, the first thing we need is that distance equals rate times time, right? Because what we're going to use is look at the picture. What's the one thing that's common in both the trips? The distance. So for my trip upstream, I know that distance equals our rate. Well, if I'm upstream, am I with or against the current? Or if I'm going, well, actually here, if it took us 4 hours, is the trip there upstream or downstream? You're right. This for 4 hours is actually downstream. So the trip back is actually upstream, right? Because it took longer. Because if I'm going upstream, is the current with or against us? Against us. So that would be our rate of our rowing speed minus the current and then times 10 because it took us 10 hours. So I'm going to give you a second to think about that. So distance is equal to the rate, so our rowing speed minus the current because we have to fight the current, and then times 10. The trip downstream, distance is equal to our row speed now plus the 6 mile/h current, right? Because that's downstream, right? Downstream. So that means it would have taken a shorter amount of time. Now times 4. So now how are we going to solve this? How are we going to solve for the person's row speed? Row speed. Yeah, so if distance is the same, we can set it equal to each other. Right, so then that 10 times r minus 6 has to equal 4 times r plus 6. Because again, for both trips, the distance is the same, right? Wherever our vehicle is, we camp, and then we got to get back to our vehicle, right? I don't want to walk part of it. The whole point is to hopefully canoe the whole way, right? So again, we're back to what we first started out with, an equation in one variable. So I'm going to get those parentheses to drop to distribute the 10 and the 4 respectively. So 10r minus 60 equals 4r plus what? 24? Now we're going to combine like terms. I'm going to add the 60 to the right, subtract the 4r over to the left. So 6r is equal to, what's these, 84. And then the last step is dividing by 6. So r is equal to 14. So our rowing speed is 14 kilometers per hour. So now I want you to take a second before you finish up. Does that make sense? Hopefully, yeah. Because what numbers or answers wouldn't make sense if our rowing speed was 6 or lower? If we could only row 5 kilometers per hour, would we ever make it back to our vehicle? No, right? We'd literally be going backwards. The current would be too strong for us. We'd have to walk off to the side or something like that. But we have to be able to row stronger than the current or faster than the current. Otherwise, we would have never made it back to our vehicle coming from downstream. Perfect. Okay, so again, if you have any questions, my email is ld1168